Okay, so year 9, this is your first class where you can change the pace of the class. You can zip through things, or you can slow it down and rewind and take your notes as you need. So what we're looking at is an extension of yesterday's work, or the last lesson's work on simplifying surds. So we saw in the last lesson that we can simplify, add or subtract surds, but only when they are the same. So square root of 2 plus the square root of 2 is the same. So 1 plus 1 is 2. Square root of 3, square root of 3 is the same. So 5 times 2 is 3. But when we had square root of 5 plus square root of 2, they're not the same, so we can't simplify. So if you need to copy any of that down, that's fine, but otherwise come to the next slide. But what we learn is that sometimes we can change the surds so that they actually get like surds. So for instance, square root of 8 and square root of 32, okay, straight away it does not equal the square root of 40 because they're unlike. But what we do is we look at the surds. So we look at number 8, and 8 is 4 times 2. 4 times 2 is 8. And then we break it up so that each of the numbers inside has its own square root sign, and then the square root of 4 is the answer 2. So the square root of 8 and 2 root 2 are the same thing, but we've just got the surd a bit smaller. Same with 32. 32 is 32 times 1 is 16 times 2 is 8 times 4, but in this particular case I'm going to use the 16 times 2, and I'll explain why. 16 comes out the front, 2 is left behind, and square root of 16 is 4. And then we've got the question, square root of 8 plus square root of 32 is 2 root 2 plus 4 root 2 equals 6 root 2. If I had used the 8 and the 4, I wouldn't get a like surd. I'm trying to get a like surd, so I have to pick factors that work. So if you want to check on your calculator, as a decimal, square root of 8 plus square root of 32 equals a decimal. 6 times square root of 2 equals a decimal, and they'll be the same. But please write that down, and when you're ready, come to the next slide. So when looking at big surds, like big numbers, we can often find a factor. So a factor is a number that multiplies that can be square rooted. Okay? So we're looking for a number that can square root. So with 12, 6 times 2 is 12, 12 times 1 is 12, 4 times 3 is 12. But 6 times 2 is no good because neither of the numbers square root. 12 times 1 is no good because if you square root 1, you just go back to itself. And this one is the useful one. Why? Because you can square root 4. So you end up with a smaller surd left behind. So instead of having root 12, I've only now got a root 3, but we need to have a 2 out the front to make them equal. Okay. Copy that down, and when you're ready, come to the next slide. So I want you to try this one for yourself. I want you to pause the tape, have a go, find 2 numbers that multiply to get 20, but one of them has to square root. And when you're ready, press play and you'll see my answer. Okay, so 20 times 1, 10 times 2, 5 times 4, that's all. One of those is good, the rest are not. The answer is, that's the useful one. So the square root of 20 equals the square root of 4. So you always put the good one that square roots out the front. So that's the answer. Square root of 20 equals 2 root 5. You'll be getting plenty of practice on this. So next part. What happens if there's already a number out the front of the big surd? So what we do is 50. It's 50 times 1. That's no good. 25 times 2. 5. 5 times 10 is 50, and that's all. One of those is good, the rest are none. Which one's the good one? And the answer is that one. So what we do is the 2 stays out the front, times square root of 25 times the square root of 2. Square root of 25 is 5. And so then we just put those two numbers together. So 2 square root 50 is the same as 10 square root 2. And again, if you're not sure, check on your calculator. To get decimal answers, you'll find it. So pause, copy down that note, and then when you're ready, come to the next slide. Okay, so once you've found like surds, once we've got like surds, now we can add, or now we can subtract, it doesn't matter. So for instance, from the last lesson, if you've got 6 square root 2 plus 4 square root 2, you have 10 square root 2. And if I got square root of 24 and the square root of 54, don't forget they don't equal the square root of 78. Can't do that. That's bad. But then we look at the numbers that make up 24, and 4 sixes are 24 because 4 is a good number. And in 54, 9 sixes are 54 because 9 is a good number. So then the 4 out the front becomes the 2. So 4 and 6 become 2 root 6. 9 and 6 become 3 root 6. Again, if you're not sure, just go back to the previous slide with square rooting both numbers, but only the good number square roots. And then 2 plus 3 is 5. So copy that down. When you're ready, come to the next slide. So we're nearly at the end of the notes. So what if the question asks you to go back to a single surd? So you've got 3 root 5, but it wants the answer as 1 surd. And so what we do is we just go backwards. 3 must have been the square root of 9. That's how we got the 3. So that means that 3 root 5 is actually 9 fives. So another example. So I've got 2 root 3, and 2 must have come from 4 as the square root. So equals 12. Okay, so copy those down and come to the next slide. So this is the exercise from the textbook. Okay, so exercise 2b. The first ones, just do one column, and these ones, these are the challenging questions. Okay, so they're the ones we're going to have to do some more of. Okay, so when you're ready, get your books out and get started.